This 256 gigabits per second external graphics card could be a game changer for mini PCs forever. Instead of relying on USB or OCU link interfaces that are limited to PCIe X4 lanes, I built this eGPU dock using a dual Micro PCIe SlimSAS 8654 interface. It is small enough to pack inside this small enclosure, making it the fastest eGPU setup we can achieve right now. An eGPU has never had a connection this fast before. With a full PCIe link speed, you could add a serious GPU powerhouse to your mini PC to play your game library, do professional work, or run AI at 100% of your GPU's potential without losing performance to limited PCIe bandwidth. In this video, we dive deep to learn more about how we can build an eGPU with 16 lanes, testing the connection and gameplay performance. How does it work? Will this eGPU dock allow you to connect an external graphics card with 100% link speed? Let's find out. Now let's take a look at the parts that I'm using to build this eGPU. I ordered 3 things to create this eGPU: a dual SlimSAS 8654 to PCIe by 16 adapter, a SlimSAS 8654 cable. This cable is electronically wired to support PCIe by 8 lanes. Compared to the OCU link connector, the SlimSAS 8654 is much larger and deeper with a secure locking clip, making for a very strong and secure connection, unlike OCU link, which is very small and shallow. If we compare this cable with a full-size PCIe by 16 riser cable, we see that the SlimSAS connector is nearly the same size as 8 lanes, and it just cuts down the voltage wires to only keep the data cables inside it. And the third adapter is a PCIe by 16 to dual SlimSAS 8654 adapter. We use this adapter to install inside the PC to add an external PCIe connection and connect to an external expansion card very conveniently. I bought these adapters from AliExpress for a total of $87, which is way cheaper than the Thunderbolt or OCU Link eGPU docks on the market. These adapters are actually available in PCIe Gen 5 if you need it, which is called Micro. Before we proceed with the eGPU build, let me clarify why I claim this is a PCIe by 16 eGPU build. First, we need to learn about how these adapters work. The SlimSAS 8654 interface is widely used in servers and data centers to connect fast U.2 drives. But manufacturers also make adapters that let you connect regular PCIe expansion cards through these same ports. Depending on your setup, you can combine 2 cables to run a single full-speed PCIe by 16 card, or you can split them up to connect 2 separate PCIe by 8 cards. So this eGPU setup will support PCIe by 16 through combining both dual SlimSAS slots. However, it will only enable port number 1 if we install this adapter on a mini PC that only supports an X8 slot. The mini PC that I'm going to use for testing this build is a Dell Precision 3260 Compact. This mini workstation features a PCIe by 8 Gen 4 slot. So now let's install the adapter into the PC. Alright, now we have an external PCIe by 8 Gen 4 slot, which is natively supported by this PC. Now let's move on to the eGPU build. I designed a 3D enclosure for my eGPU dock to accommodate a dual-fan GPU and an internal PSU inside the case. I 3D printed the files using ABS filament with 100% infill for the bracket and backplate and 40% for the case shell. And here's the 3D printed case. Here's the main case shell. I designed it with ventilation on all sides so it can keep the GPU cooler even without a case fan. And here's the mounting bracket. I designed this bracket to mount the SlimSAS adapter on the top and an PSU at the bottom. And here is the backplate. I designed this part to be 4 millimeters thick and printed it with 100% infill to ensure the impact resistance of the eGPU dock. Now let's assemble the eGPU components. Place the SlimSAS adapter on the mounting bracket and secure it with 4 screws. Now let's mount the PSU to the mounting bracket. For the PSU for this build, I chose an HDPlex 250-watt PSU. At a $150 price point, it's a bit too expensive, but I think it's worth it for me since the eGPU link speed could justify the cost. For this build, I only need the PCIe power cable. The board has no 24-pin connector and only uses a 6-pin PCIe power cable input. Since there is no 24-pin cable connected to the PSU, I need to pre-activate the PSU by jumping the PS on pin to a ground pin using a wire jumper cable. Now let's mount the PSU to the mounting bracket and secure it with 4 screws. Connect the power cord extension cable to the PSU. Mount the power cord connector to the backplate and secure it with 2 screws. Now mount the backplate to the mounting bracket and secure them with 2 screws. So now, let's connect the SlimSAS cable to the adapter. Since this SlimSAS adapter uses an internal port, I decided to set up a fixed cable on the eGPU dock side. Make sure the cable snaps in and is secure in the slot. I secured the cable with a zip tie to ensure it stays straight and fixed. Now, let's squeeze the SlimSAS cable into the cutout hole on the backplate and secure the cable with a zip tie to ensure it won't pull out during day-to-day usage. Let's move on to the GPU installation. For the GPU, I chose my Asus Dual RX 9060 XT 16GB for this build. Let's install the GPU to the eGPU dock. Connect the PCIe 8 pin to the GPU. Since the other PCIe 8 pin can't reach the SlimSAS board, I'm using an extension cable. Let's plug the PCIe power into the SlimSAS board adapter. Let's do some cable management to make it look neater. Alright, now the whole eGPU assembly is complete. Let's slide the eGPU into the enclosure. Secure the eGPU dock to the case shell with 4 screws, 2 at the top and 2 at the bottom. The last thing to do is install the GPU bracket. Alright, now the first PCIe by 16 eGPU dock has been created. Let's preview the build before moving on to check and test the eGPU dock. Alright, now let's put our GPU to the test. Let's plug the power cord into the eGPU and connect the SlimSAS cable to the mini PC. Now, real quick, since this is not a full PC build or upgrade, we are only checking the GPU. I'm using GPU Z to check the GPU installation details. And here, as expected, we have an AMD RX 9060 XT 16GB running at PCIe X8 Gen 4, which is the same as what is natively supported by this mini PC. I also want to check the thermal performance of the GPU while it's running in my 3D enclosure. So now let's run a GPU stress test with Furmark. The GPU temperature is 70 degrees and the hotspot temperature is 87 degrees. Alright, let's try some games with this setup to see how this eGPU performs in-game. The first game that I want to test is Forza Horizon 6 at 1440p with high settings with no FSR or frame generation. Gameplay achieves around 150 frames per second. The GPU temp is around 70 degrees Celsius. The CPU temp is around 65 degrees Celsius, since I capped the CPU power to 65 watts to make the i9 run cooler in the 2.3-liter mini PC. Let's move on to God of War Ragnarok at 1440p high settings, with no FSR or frame generation. Gameplay achieves around 98 FPS. Honestly, for 1440p high settings without any upscaling help, that is absolutely massive for a mini PC setup. Next, Red Dead Redemption 2 at 1440p high settings, with no FSR or frame generation. I used the built-in game benchmark to test this game. After the benchmark completed, it showed a minimum of 60 FPS, a maximum of 180 FPS, and an average of 117 FPS. The last game that I want to test with this setup is Cyberpunk 2077 at 1440p with no FSR and no frame generation. The gameplay achieves around 83 FPS. Getting over 80 frames per second in a notoriously heavy title like Cyberpunk without any upscaling is just crazy for a tiny system like this. Overall, I'm really excited that I managed to make this project come to life. I was thinking about an external eGPU that can support more than PCIe times 4, but I couldn't find an adapter featuring the mini PCIe facing externally, like the one I used in this video. The results are absolutely amazing, and it was way easier to set up than I expected. I hope you like this setup. If you have any suggestions or opinions, please leave a comment below. Thank you for watching.